Good morning, all of you. Today we are going to study the last topic of our chapter 2, that is functions. In the last video, we did exercise 2.2, that is based on our topic relations. Okay, so today we are studying function. So first of all, a function is a special type of relation. Okay, now what is the difference between function and relation is that in function, when we talk about function, every element of set A here is means domain. Okay, means every element of set A means domain has one and only one image in set B. In set B means in codomain. Okay, in relation there can be many images of one element, but in function there will be only one image. This is the only difference between function and relation. Okay. So, example 11 is given to us. In that we have to check whether which of the following is function. Example 11. First part they are given to us is R is equal to 2 1 3 1 4 2. Okay, now first of all what we can do, we can make our domain is what, 2 3 4. You can say 1 2 3. Okay, so 2 is related with 1, 3 is also related with 1, 4 is related with 2. Now while checking that whether it is a function or not, we have to check two things. First, every element of domain has image. Okay, first thing is that, now check, every element has image. Okay, so it is true. Second, it has one and only one image. Okay, so you can check, image of 2 is what, 1, image of 3 1, image of 4 2. Now any of them do not have two images, so this point is also true. So therefore what we can say, that it is a function. Okay, understood? Now in second part they are given to us as R is 2 2 2 4 3 3 4 4. So again we will make our domain and range. So it will be 1 2. So we can say 2, 3, 4. And this will be 2, 3, 4. Okay. So we'll check 2 with 2, 2 with 4, 3 with 3, and 4 with 4. Okay. Now again we have to check our both the points. First point is what? Every element of domain has image. We can check every has. So first is true. The second is they must have only one and only one image. Means they must have one and only one image. 4 has only one image, that is 4. 3 has only one image, that is 3. But 2, you can see it has two images. One is 2 and another is 4. So second point is not satisfied here. So we can say that this relation is not a function. Okay. So similarly, third part you can check and you will get it is also a relation. Okay. So next we are going to study some functions. Some functions with their graphs. Okay. And their graphs. Okay. So first is identity function. Identity function. So identity means what? Identity means remains same. Okay, means identity does not change. Now you can say f of x is equal to x. Now we also represent our f of x with y. So which we can say that y is equal to x. Now we will keep some value of x and we will get value of y or f of x. So when x is equal to 10, y equal to 10, x equal to minus 4, y equal to minus 4, x is equal to 0, y is equal to 0. So in this way you can take as many values you want, and if then we will draw graph, then what we will get, that this is our Cartesian plane. First of all, here we will mention 1, 2, 3, 4, 5, in this way 6, 7, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, 1, 2, 3, 4, 5, 6, 7, minus 1, minus 2, minus 3, minus 4, minus 5. We can take one value of x as 6, and then what we will get? Y value also 6. So using this we will draw this graph. It is our origin O. So first of all, x is equal to 0, then y is also 0. This point lies here. When x is minus 4, y is also minus 4. So it will be here. When x is 6, y is also 6. So it will be this. If we will draw this properly, then we will get a straight line in this way. Okay. It is the graph of our identity function. Okay. Now we can check here. We can keep any value of y. Okay. That means what? X belongs to R. R means real numbers. Okay. So that means what? Our domain of identity function is what? R. Any number we can take. And what will be its range? Its range will also be R. Whatever the value of domain we keep, we will get the same value of range. So it will also be R. Okay. Understood. Next is constant function. Okay. We can represent this by y equal to f of x equal to c. C can be any constant. Okay. Where our function f is from R to R. Okay. That means, this means what? This means that our domain, this represents domain. Our domain is R, and this represents our codomain. That means our domain and codomain both are real numbers. Okay. So we can say that C is 3 here. Okay. Now using this value, we will try to draw our graph. So when x is 0, y is 3, x is 5, y is 3, x is minus 2, y is 3. Okay, because there is no x here, it is constant only, and this will remain same as it is. We can keep any value. And if we will draw this graph, then what we will get? If this is our graph, 1, 2, 3, 4, minus 1, minus 2, minus 1, 2, 3, 4, 5, minus 1, minus 2, minus 3. So depending on these values, what we will get? When x is 0, y is 3, this. When x is 5, y is 3, here. X is minus 2, y is again 3, here. So what do we get is a straight line, okay, that will be parallel to x-axis. Okay. So this is our constant function. Now if we talk about its domain and range, domain will be what? Domain will be R. We can keep any value of x here. But what we will get? Our range will be what? Our range will be C, which is 3 here. 3 is in this case, because at every value of x we are getting the same value. Can keep any. So this is our constant function. Next is polynomial function. Now third is polynomial function. Now this is a function from R to R. Okay. Now we can say that our y will be equal to f of x is equal to a0 plus a1x plus a2x square plus in this way till a n x n. Here, okay. So polynomial is function from R to R, where for each x in R, for each x in R, for means for every value of x that belongs to our relay R means real number. So that means value of x will be R. Our y is this. Here two things are there. First is n is non-negative. Okay, that means that this n will never be negative. Second, it was first, and second is this a0, a1, a2, like this till an that belongs to R. Here these are constants. Okay, this is a polynomial function, and the graph of polynomial function depends on degree of function. Okay, graph depends on degree of function. Now if we take example, that is given example number 13, y is equal to f of x is equal to x square. It is our function and x belongs to R. So they are given some specific values of x in this question, that are -4, -3, x they are given -4, -3, -2, -1, 0, 1, 2, 3, 4. These are the values x given, and they are asking the value of y. So y will be what? Square of this. This is 16. This will be 9. This will be 4, 1, 0. Again 1. Square of 2 is 4. Of 3 is 9, and of 4 is 16. So these are the values that we got. So we can draw its graph. -1, -2, -3, -4, 1, 2, 3, 4, 5, 6, 2, 4, 6, 8, 10, 12, 14, 16, -2, -4, -6, -8, -10, -12. Now we can draw this graph. When x is equal to -4, y is 16. When x is equal to -3, y is 9. When x is equal to -2, y is 4. When x is -1, it is also -1. When x is 0, y is also 0. When x is 1, this. For 2, this. For 3, here. And for 4, 16. So what we will get if we join these lines? We will get a parabolic curve. Okay, if we draw properly using scale and paper. Okay, this is for square function. And if we talk about cubic function, then we will get line somewhat in this way. Okay, in this way. This is very steep. That means the values of this function increase very rapidly. Okay, it is also for square function that all the values of y will be positive, and in cubic function y values will be positive for positive x and it will be negative for negative x. So it lies in first and third. Okay, you can see example number 14. It is given there. So remaining functions we will study tomorrow. So your homework is to complete your notebook till exercise 2.2 and solve example number 10, 11, 12, 14 till 14, means from 10 to 12 in your rough notebook. Okay, thank you.